Example number 5. A man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the route 20 feet from the path and is kept focused on the man. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? Now we draw the picture for this. So imagine this is the path that the man walking on this path. And we have the spotlight is right here. And they said that the locate of this light is 20 feet away from the path. So this is mean 20 feet. So we have the light come to this man when he's moved to the left or moved to the right. So we have the angle theta. So angle theta will change depending on the time, and the man also, the position is also changed depending on the time. So x and theta, both of them change according to the time. So the problem gives us 4 feet per second. That means this is the change of the x over the time. So that is given dx over dt is 4 feet per second. And the question asks us that what is the rotating at what rate when the man is 15 feet from the point of on the path closest to the searchlight. So this question asking us to find the angle theta, the change of the angle theta with respect to the time t, and is given that when x is 15 feet. So we know that the 15 feet we will plug into the equation that you take the derivative of d theta over dt, okay? So now we have the graph, and this is a right triangle. So we have the angle theta. The x is the opposite, and the 20 is the adjacent. So we have the formula for the tangent of theta is opposite over the adjacent and equal to x over 20. You notice that you do not plug x equal to 15 for right now. We are finding the change of theta, d theta over the dt. Then we will plug x equal to 15 at that time. Okay. Right now, the angle theta and the x, they are still variable. And now we take the derivative for both sides with respect to the time t for both sides. So we get tangent of theta, the derivative will be secant squared theta equal, this is the same thing as 1 over 20 times x, so that is a constant. So we have 20 dx dt. So we are using chain rule. The derivative of x is 1, right? Then we solve for d theta dt. We will have 1 over 20 secant squared theta dx dt. And secant square, 1 over secant square is cosine square dx dt. Dx dt we know is given to us in the problem, so that is 4 feet per second. We will plug into here. So we do not know the angle theta. So we need to go solve for it, right? So we have 20 in the bottom, dx dt. Now we have to find angle theta. And now you can use x equal to 15 now. So x is 15, and the angle theta, cosine of angle theta, the formula is cosine of angle theta is adjacent, which is 20 over the hypotenuse. So we use the Pythagorean theorem to find the hypotenuse. So that will be 20 square plus 15 square, and that is the square root. We will take positive number because we are talking about length. This is 400 plus 225, so we get 625. Square root of 625 is 25. So the hypotenuse is 25. So 20 divided by 25. And that gives us 4 over 5. Now the cosine we will plug in is 4 over 5 square. 4 over 5 square divided by 20 times dx dt. So 16 over 25 for 4 over 5 square times 20 and times dx dt. Dx dt is 4 feet per second. So times 4. So all of this, you cancel this, is like 5. So that's like 16 over 125 and it's equal 0.128. So it means that the angle of theta will rotate 0.128 radian per second.